Question 43 says, the closer the star, the smaller its parallax angle. Is it true or false? It's false, right? Because the distance is 1 over the parallax angle, or the parallax angle is 1 over the distance, right? So as the distance increases, the parallax angle gets smaller as I'm dividing with bigger and bigger number, right? So this is false. Okay, a star has a parallax angle of 0.04 seconds of arc. What is its distance? So now we again need to use this relation here. The angle is given, we have to figure out the distance. So the distance is, because the angle is 0.04, I will get this many parsecs, right? And you can do that in your head. One way to do this is if I multiply the numerator and denominator by 100, I will have then, this is the same thing as 100 over 4 parsecs, right? And when I divide 100 by 4, I'll get 25. So the numbers that I give are always simple. You can do the calculation yourself, so the correct answer here is B. But as a security blanket, you can bring in the calculator if you need it. Although one thing that I learned for many years ago while teaching, when I started here at Brock, first year introductory physics, I tried to teach students that before they punch in the numbers, they should get an estimate in their head for the ballpark figure of the end result. And the reason is that when you punch the buttons on a calculator, often one can make a mistake. So say you made a mistake and you get some number, but if you have the right idea as to how big your answer should be, you immediately realize that something has gone wrong, and therefore you can recalculate that, okay? So it's good to have a feeling, before you use the calculator as to what roughly the correct result is. Okay, so now the reverse thing. The star is at the distance of 10 parsecs. What is its parallax angle? Well, now I need to use this relation here. So the parallax angle is, the distance is 10 parsecs, and then when I use this, my angle is in seconds of arc. So this is 0.1 second of arc, right? So again, the correct answer is B. Okay, now one question that combines this relationship here and the connection between parsec and light year. The question is 46 is, if a star has a parallax angle of 0.05 seconds of arc, how far away is it in light years? So in the first step, I have to calculate its distance in parsecs, which I can do because I know the parallax angle given in the seconds of arc. I just use this relation here. And then I multiply my result with that conversion factor of 3.26 to get the distance in light years. So first step is that the distance is 1 over 0.05 parsecs. And this is, again, this is just going to be 20 parsecs, right? Using the same technique at here, if I multiply numerator and denominator with 100, this is the same as dividing 100 by 5, and the result is 20. So the distance in parsecs is 20 parsecs. And then in step 2, I have to convert this into light years by multiplying by a factor of 3.26. So step 2, I have 20 parsecs times 3.26 light years for each parsec, right? So I see without doing any calculation that the leading number, this is like 3.3 times 20, that is going to be 66. So again, the correct answer is B. I give as possible answers numbers that are so different from each other that, you know, even without using the calculator, you realize that when you multiply 20 with 3.26, the result is going to be closest to 66.